Okay, so what's the last one we did? We did number 27. Is that the last one we did? 27? We did 29? Okay. Okay, so we're on to question number 31. 31's a little bit different. Okay, so let's look at number 31. And we're going to try to get through all of this. Okay, so this is what worksheet this is. 1-4. 31. Okay, so we have y to the 3/2 equals 5y. Okay? All right, so how we're going to solve this one is this. This one's a little bit weird. First off, and I want to make sure you guys understand, I think I told you this the other day, and I said that I had to amend something I taught you guys in Algebra 2. I got to amend it again. I think I told you guys in Algebra 2 that any quadratic is always supposed to equal 0. Second degree is supposed to equal 0. And then I said quadratics or higher, so second degree or higher has to equal 0. So if it was like, if I give you something like this, x to the third minus 2x equals 7, you should make that equal 0 because it's third degree, okay? It really shouldn't be anything second degree or higher. It's really anything higher than first degree. Anything higher than first degree must equal 0, okay? So is this higher than first degree? Yeah, because 3/2 is 1.5. It has to equal 0, okay? So let's make this equal 0, so let's minus our 5y. Minus 5y. And we can't combine these because they have different exponents. We have y to the 3/2 minus 5y equals 0. So this will be the last time I say this. But again, originally I said back in Algebra 2, quadratics have to equal 0. Second degree have to equal 0. Then I said second degree or higher has to equal 0. It really should be anything higher than first degree. Anything higher than first degree should equal 0, okay? And Andy, how we're going to solve something like this? If you're not sure what to do, it's never a bad idea. Factor. Could I factor something out of those? Take a y out. Y to what power gives you y to the 3/2 power? Careful. Remember, when you times, you add. This is y to the first. 3/2 is the same as 1.5. So y to the half minus, because y to the first times y to the half is y to the 1.5, which is y to the 3/2, same thing, okay? All right, and then we take out a y out of 5y, what are we left with? Y. This is one problem we never would have done in Algebra 2. We've never done a problem like this, okay? Okay. Whoa, 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 whoa. Did I say y or 5? Did I say 5 and wrote y? I don't know where that y came from. I apologize. Y times 5, okay? All right, so remember this times this is 0, so either this is 0 or this is 0. So either y equals 0 or y to the 1/2 minus 5 equals 0. This one's already solved for. How are we going to solve for the other one? Real simple step. Next step. Do what? Still hear what you said. No. Let's add 5 to each side. So y to the 1/2 equals 5. Okay, it's getting hot in here.
It's just getting nicer.
Now, something that I did not tell you enough in Algebra 2, part of it was because we was already in lockdown, but something you need to understand is another name for the half power, 2 words. Y to the half power. How can I rewrite y to the half power? The what root of what? What do I, first root or the second root? Second. How do I remember I write 2 first? Well, 2 is the last thing I wrote, so I rewrite it. 2 is the first thing I write. So there's nothing wrong with writing it like that, but instead of saying the second root of y to the first, what's a nicer way of saying the second, we don't say the second root, the square root of y to the first, or just the square root of y, okay? So what I want you to understand is this. Y to the 1/2 power, it's the same thing as the square root. It's the same thing. The half power is the square root. What's the 1/3 power the same as? The cube root. 1/3 power is the cube root. So this is the same as the square root of y equals 5. How do we get rid of square roots? What cancels square rooting?
Exponents, right?
Yeah? One word you could say though. What cancels square rooting? Squaring. What gets rid of cube rooting? Cubing, okay? And again, some students think the same thing, square, square. No, they're not. They're total opposites. It's like saying adding and subtracting the same thing. No, they're not. They're inverses, okay? Squares and square rooting are inverses. Square each side, and we get y equals 25. So the answers are 0 and 25. So let's backtrack here. I want to make sure you guys didn't get lost in what all we did here. We made it equal 0. We factored out a y. So either y was 0, that's easy, or y to the half minus 5 is 0. So we added 5 to each side to get rid of the half power. That's the same as the square root. We square each side. Okay? All right, let's look at the next one. All righty, 33. This one should be an easy one. 7 minus 5x. Okay. Any idea how we're going to start this thing? Pretty simple first step. How are we going to get rid of that square root symbol? Square both sides. Square this side, square this side. These cancel. 7 minus 5x equals 64. And I'm not going to explain the rest. You know how to do it. So you get negative 57/5. You can make it a decimal if you want. I'm not going to. Square each side. So we have 7 minus 5x equals 64. Subtract 7, divide negative 5. That should be a pretty straightforward one. Now, 35. 35 is quite a bit tougher, okay? Quite a bit tougher when you come to 35. Okay. So, in 35 we have x equals 3 plus, and we go 5x minus 9. This one's going to take quite a bit more work, okay? Any idea what our first step is? Our first step's really easy. It's a really easy first step. And once we say it, I want somebody to tell me why we're doing what we're going to do. Any idea what we should do first? It's a real simple first step. Say that again? Eventually, not yet. That's the second thing we're going to do. Minus 3. Why? What are you trying to do? If you minus 3, that's exactly what you do first. We're going to square after that. Why do we minus 3 first? Get the radical or get the square root by itself. That's what you want to do, is get the radical by itself. Minus 3, minus 3. So x minus 3 is x minus 3 equals radical 5x minus 9. Now, what's different about this question compared to the one we just did a second ago?
The 3.
Say it again?
The 3 for that.
Yeah, and not just that, but here you have the radical, over here you have a number. Here you have radical, over here you have a number and a variable, okay? Now, Lexus said square both sides, and we're going to square both sides. But you need to understand those. When you square both sides, weird things can happen, okay? For example, true or false? 5 equals negative 5. False. Square both sides. Square this side, what do you get? 25. Square this side, what do you get? True or false? True. So, when you square both sides, you can take false statements and make them true, okay? I mean, for example, if I want to make sure, before we go any further, I want to be very clear on this. If I asked you this right here, listen carefully, this is a very basic, but also one that students forget a lot. What is radical 9? 3 and negative 3?
3 or 9.
It's only 3. It's only 3. Now, hang on a second. I want to be very clear. I'm going to say this very slowly, okay? You're sitting there going, well, negative 3 times negative 3 is 9. I agree, it is. The radical is you might think it's square root. That's why I think Meerkat said square root and I said radical. You might think it's the same thing. It's almost the same thing. It's almost the same thing, okay? Radical 9 means the positive square root of 9. So it's just positive 3. That's why if I solve something like this, x squared equals 100, that has 2 answers. What are they? 10 and negative 10. Because 10 times 10 is 100, and negative 10 times negative is 100. Here's why. When I put the radical symbol in there, I always tell you, don't forget to put something else there. What do you put in front of that? The plus or minus, because if you don't put the plus or minus, you only get 10. Okay? So, the radical is just the positive square root. Okay? Just the positive. All right? So,
Also negative, radical 9 would be negative 3?
yes, yeah. If I give you this, okay? If I said radical, that's 10, Now it's negative 10. The radical is the positive square root. The negative radical is the negative square root. Okay? That's why if you put the plus or minus, it's both. Okay? But the radical just by itself is just the positive square root. Okay? So, what happens here, though, is this. I mean, if I would have done this right here, back here on this question, okay? Think about this for a second. Think about what we just said. If I would have put a negative right here, would that have changed my answer on 33? If I squared this side, would we still get this right here?
Yeah.
Yep. If I squared this, would I still get 64? Yeah. So would it change it? Yes, it still would. It still would. You might think, wait a minute, no. Here's why. A radical is the what square root? The positive. What radical equals negative 8? No, that's not what I said though. What radical is the what square root? This is positive. What positive equals negative 8? There isn't one. There isn't one. But if I square both sides, then this would have no solution when you square both sides, okay? But since it was positive 8, it did have solutions, okay? Now, is this side, like right here, is that positive or negative? It's positive because it's 8. It's positive 8. Is this positive or is this negative? X minus 3, is that positive or negative? It depends. If x is 10, is this positive or negative? Positive. If x is 1, what's 1 minus 3? It's negative. So it depends, okay? So here's what we got to do. Seeing as how we have an x over here, we're going to square both sides, like Alexa said 5 minutes ago. We're going to square both sides, but we have to check our answers. You've got to. Just like when you have x on the bottom, remember earlier in this worksheet, you got to plug in your answers to make sure they work. Sometimes you might get no solution. So let's square both sides. Square this and square all of this. Okay? So x minus 3 squared means x minus 3 times x minus 3 equals, these cancel, 5x minus 9. So a lot of talk here for the last 5 minutes. I want to make sure you haven't lost track of what we've done. All we've done so far is two things. We subtracted 3 from each side. Why did we subtract 3? To get the radical all by itself. Then we're going to square both sides to get rid of the radical. Okay? But we've got to check our answer. Why didn't we have to check our answer on this one? No x. There's no x over there. 8's always positive 8. Okay? But if this was 8x, is 8x positive? Depends on what you plug in for x. Okay? All right, so let's FOIL this thing out. X squared, I'm going to skip a step here. Minus 3x and minus 3x is minus 6x. Plus 9. It's 5x minus 9. Now what? Yeah, well, they're, huh? Minus 9?
No.
Or not minus 9.
Add 9.
Add 9? Keep talking. And? Don't add anything. Add 9 and then do something else.
Subtract x squared.
Not x squared.
5x.
Why? What are you doing?
Get 0.
If we do that, we have x squared minus 11x plus 18. Gotta have 0 on one side. Now what? Somebody said it. Factor. If you're not sure what to say, if you're not sure, just say factor. You're right most of the time. Okay? And hopefully at this point, and I'm not making fun here, when you see these numbers like 18 and 11, in this class, at this level, there should be some numbers that are popping into your head pretty quick. When you see 11 and 18, any idea what numbers we're thinking of right here when I see 11 and 18? What's so special about 9 and 2? So x and x. To make it positive, it's either plus plus or minus minus. It's going to be minus minus, and like Alexa said, 9 and 2. So what makes 0? 2 and 9. What was that? Well, just we done?
2 can't be an answer.
I'm not saying yes or no.
Because if you plug it into...
Okay, so are we done? Are we done?
No.
Why, what are you doing?
You gotta check.
Do you have to check your answers?
Yeah.
Yes, you do, because there's an X on both sides, okay? You gotta check these, okay? So let's check them right here, okay? Let's plug in, and now here's the deal. Does it matter where I plug, I'm gonna plug in 2 and 9 in for X. Does it matter where at in the equation I plug in 2 and 9? Actually, it does, okay? It either has to be at the very, I would plug in at the very beginning. But you don't necessarily have to at the very beginning. You just have to do it sometime before what? What's the step that kind of makes weird things happen?
The square.
Squaring both sides. You better do it. You can do it before, it's got to be before you square both sides. I'm going to do it at the beginning, okay? Let's plug in 2. I'm going to plug in right here at the very beginning. 2. This side's 2. Okay, this is just 2. If I plug in 2 here, 5 times 2 is 10. 10 minus 9 is 1. Radical 1 is 1 plus 3. 1 plus 3 is 2? No. 1 plus 3 is 4. So 2's out. So that means 9 must be right?
No.
Not necessarily. There might be any answer. Maybe nothing works. Okay? And the reason why we think, well, where's our mistake? There was no mistake. What happens is this. When I plug in 2 here, okay? If I plugged in 2 here, we got 4. If this would have been, I forgot, I don't want to confuse you guys. Let's just go with 9. See if 9 works. This side's 9. This side over here is 9. Let's just remember this is 9. 9 times 5 is 45. 45 minus 9 is 36. Radical 36 is 6. 6 plus 3 equals, what did we say that was?
9.
So does that work?
Yeah.
Yep. And not to be mean, but if students are like, what if we forget to check our answers? Well, you forget to check your answers, you put 2 and 9, you get marked down. 2 is not an answer. 2 is not correct. Okay? And that's no different than saying, you know, x plus 1 equals 7. And you say, my answers are 5, 6, 7, and 8. Okay? Well, yeah, one of them's right. The other 3 are wrong. Okay? If you put that down, you're going to get marked down because they're not all right. There's only one right answer. 37. Okay. Never did one like this. 5y4 minus 7y squared plus 1 equals 0. I would just watch on this one. We've never done anything like this, not even in Algebra 2, okay? What do you think we ought to do first? What do you think we should do? Factor. Don't just watch. Just watch. There's a reason why I'm telling you not to, okay? Let's try and factor this thing. What goes to 5, 7, and 1 besides 1? Anything? Nothing. So, don't write this down. 5y4. How do you multiply and make 5y4? 5 and 1, 5 what and 1 what? How do you make y4? 5y squared and y squared? It could be 5y3 and y1, but do you see any y3s or y1s up here? Do you see any y squareds up here? Yeah, so now, how do you get a positive? Plus plus or minus minus? It's going to be minus minus. There's only one way to make 1. 1 and 1. Oh, crap. This is the one I thought it was. Oh, wait, yeah, it worked. Good, 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 good. Okay, my outers are negative 5y squared. My inners are negative 1y squared. Yeah, that's negative 6y squared. Is that what we want? No. How else do you factor it? You can't. You can't factor it, okay? First off, how many answers this thing got? This goes back to Algebra 2. There's 4. There's 4 answers, okay? We can't factor it, though. So, if you remember from Algebra 2, we learned like factoring. We also did completing the square. We also learned quadratic formula. Remember, the quadratic formula was good because it always works. It's bad because it takes a long time. Factoring doesn't always work. We tried to factor it. It didn't factor. Okay? But, you know, like I say, we wanted to factor, but we couldn't. This is sort of a tricky one, okay? Can we use the quadratic formula in this? Why do you shake your head no? That's what you're supposed to say is no. Why do you think you can't use the quadratic formula on this one? What does quadratic mean?
Because it's to the 4th power.
What is quadratic? To what power?
Just a second.
That's not a quadratic. This is a quartic. Quartic. Is there a quartic formula? In all honesty, I don't know. I know there's a cubic formula, and I'll show it to you later. Oh my gosh. I've never used the cubic formula. It's in one of my college algebra texts, though. You think the quadratic formula is confusing? The cubic formula will blow you away. Okay, I don't even understand it. Is there a quartic formula? I honestly don't know. Okay, so good. Mir Kate answered exactly what he's supposed to. He said, yeah, he thinks he can't use the quadratic formula because it's not a quadratic. And it's not yet. It isn't yet, okay? So we're going to take this one real slow, okay? We're going to do a substitution. Now, we're going to do about 2 or 3 questions in a row here. And I have a really hard time explaining how to do this, but I'm hoping that somebody in here, I have absolutely no idea who, is going to say, it's easy. I'll explain how to do it, how we can do this. So just hang with me for a couple examples. Okay, we're going to do a substitution. Okay, let u equal, in this case, y squared. Write that down. And actually, write the word let. Let u, you can use whatever letter you want other than y, okay, because we already used y. We're going to let u equal y squared. Okay, u is y squared. So, if u is y squared, what's y to the fourth? Huh?
U squared?
U squared. So what? So I left some out. So what? 5u squared. Minus, what's 7y squared if u is y squared?
7U.
Now can I use quadratic form, Meerkat?
Yeah.
Why?
7.
This is a quadratic now. Now it is. Now if you're something, how can you just change that? You'll be okay. Just keep hanging with us, okay? Now we could try to factor this. It's not going to factor. It's not. We already tried to factor, okay? So we're going to use the quadratic formula. I'm not going to write down A, B, and you should know A, B, C. 5, negatives, bunch of negatives, negative 7 and 1, okay? So negative B is positive 7, plus or minus the square root of B squared. Negative 7 squared is 49, minus 4. A times C is 5 times 1, over 2A, over 2 times 5, which is 10. Let's clean this up. I'm going to skip steps here. 7 plus or minus. We times first. 4 times 5 is 20. 49 minus 20 is 29. Now, what is that? I mean, how many answers is that right now? 2. 7 plus radical 29 over 10, and 7 minus 29, radical 29 over 10, okay? Now, what is this, though? This is what did we just solve for? U. That's what U is. Sounds like bad English. U is. Okay? UB, whatever. Now, if you stop there, you won't get full credit. Because look at that, there was no problem.
That's Y.
Yeah, there's no U's. So can we just change the Y? No. Watch carefully. That's what U is. Okay? Well, what is U?
Y squared.
How do you know that? That's what we wrote down. I said, write that down. U is y squared. So where I see a U, I can cross it out and make it a what?
Y squared.
Y squared. I'm trying to solve this for y. What's the last thing we do? How do I solve for y now? No. Square root it. Get rid of that square by square rooting. So what do you do over here? Square root 1 of this. The whole thing. And what do you put in front of it? Plus or minus. So I want you to write this down. Y equals plus or minus radical 7 plus or minus radical 29 over 10. You got radicals inside radicals. You think those are ugly? Holy, you thought radicals were ugly. We got radicals inside radicals that are fractions. Okay? Now how many answers is that right there?
4.
There is 4. Now if you want to go ahead and write this down and stop writing, okay? If you're sitting there going, I don't see all 4 of them. Here's where they're at. You're done writing. After you're done writing this, just watch. One of the answers is 7 plus radical 7 plus radical 29 over 10. Another answer is negative radical 7 plus radical 29 over 10. A third one is radical 7 what? Minus radical 29 over 10. And the last one is positive, negative radical 7 what? Minus radical 29 over 10. Plus plus, minus plus, plus minus, minus minus. Those are our 4 answers. That was supposed to have 4 answers. You don't have to write that out, okay? Those are some ugly answers, okay? That's a tough one, okay? Never did anything like that in Algebra 2. Okay. Next one. Now, if you're sitting there going, how did you know you're supposed to let u equal y squared? How do you know that, okay? I can't tell you yet. We're going to do about 2 more examples. Then somebody's going to say, it's easy. All you got to do is this. Okay, number 39. 39, so we have 36 x to the negative 4th minus 13 x to the negative 2nd plus 1 equals 0. Okay, so, all right. So we're going to try to factor this thing, but we're going to do a substitution here. Let u equal, any idea what we're going to let u equal?
X negative
X to the negative what?
2.
Good. Just yes or no on this, okay? Do you think you know how to explain it? Don't say, do you think you know how to explain that it's going to be the negative second? Or are you just guessing right now? Okay, well,
Looking at
we'll
the
do one
last
more.
question.
Okay. Well, u equal, now here's the deal. Here's what you don't do, okay? You may not understand why it's x to the negative second yet. Hopefully by the next one you'll understand, okay, after we do 3 of them. The one substitution you don't do is don't ever say, let u equal x. Do you understand why? You can.
Now they just equal each
Huh?
other. Now they just equal each
Because
other.
it's already a quadratic. If you-
Yeah, but I mean, if you say let u equal x,
Then the exponent stays the same, right?
what changes?
The-
It's kind of like this. 3y plus 7 equals 11. I'm going to do this. 3x plus 7 equals 11. Which of those is harder to do? It's the same, it's literally the same thing, okay? You didn't make it easier or tougher. If you say let u equal x, you're just going to change all your x's to u's. And it's not going to hurt, but it's not going to
Can
help.
we make u equal to the largest like common thing? So x negative 2 squared goes into both x and the both of them. But it's like
Let's do one more problem after
out.
this. Let's finish this one and do one more. You're going to make it, maybe, my answer is to that is maybe, okay? I want somebody to explain it, and it might be you. It's going to say it very, very simply, how you can tell. Okay, so let's do this. If u is x to the negative second, what's x to the negative fourth? U what? U squared. So what's 36 x to the negative fourth? U squared minus 13, what's x to the negative second? U plus 1 is 0. Now, I didn't say these are easy questions by any means, okay? But what I'm saying, some students wonder, well, why do we do substitution? This is not an easy problem, but when you do the substitution, it makes it easier. I believe this one does factor.
Because now you're not using negative.
Right, yeah, it makes it easier. It makes it easier, okay? This, I believe, does factor, okay? 36u squared. You'd like to do what and what? If it was 36. Yeah, I think it's 9 and 4, though. I'm almost positive it's 9u and 4u. What comes after 9u and 4u? Plus plus, minus minus, or plus minus? Minus minus. And there's only one way to get 1. 1 and 1. Is that right? What are my outers? My outers are what?
Negative 9.
Inners?
Negative 4.
What's negative 9, negative 4?
Negative 13.
Okay, so what makes this equal 0? What makes this 0?
1.
Careful, there's a 9 there. 1 over 9 and 1 over 4. I want to make sure you guys haven't forgot that from Algebra 2. If I give you this right here, 2x minus 7, 4x plus 3 equals 0. If you can't answer this right now, it's really okay, but in about 30 seconds, you better be able to answer it. You should be able to tell me immediately without doing any work what the answers here are. 7 over 2, negative 3/4. How do I get these answers? Opposite over this. Because I mean, think about it. This times this is 0, so either this is 0 or this is 0. If this is 0, in 4 words, how do you solve that? What's the first thing you do? Add 7, divide 2. Add 7, divide 2. How do you do this one? Minus 3, divide 4. Minus 3/4, okay? So, add 1 over 9, add 1 over 4. What is 1/9 and 1/4? What is that? That's what u is. I don't want u, though. I don't want y either. I want x, okay? What is u? X to the negative second, okay? Real quick here, more review. 5 squared is 25. What's 5 to the negative second? And do not say negative 25. It's not negative 25. Remember negative exponents? They don't make them negative. That's the same as 1 over 5 squared. So it's not negative 25, it's what? 1 over 25. So what's another way of saying x to the negative second? 1 over x squared. And I think you should be able to figure this out in your head now. Look at all the numerators.
Oh.
They're all the same. So what does that say about the denominators? They're the same. So what would x have to be if it was 9? What? Thought you said it. No. These are 1 over x squared equals 1 over 9. The tops are the same, so the bottoms are the same. X squared is 9, so x has to be what?
3.
You're half right.
4, 2.
Well, okay, 3 or negative 3.
Oh, negative 2 or 2.
So we have 4 answers. 3, negative 3, 2, negative 2. Which kind of makes sense because based on what I've always taught you, you're supposed to have how many solutions?
4.
Not, I mean, the way I've taught you, no, you shouldn't have said 4, you should have said what? Which doesn't really make sense. Negative 4 solutions, which doesn't make sense, but 4, okay? All right, that was a doozy. Okay, one more of these. Then we'll start getting into a little bit easier ones. Okay, somebody in here is going to tell us very simply after we start this one how you can tell what we're supposed to let u equal to. Okay, so don't tune out because somebody's going to tell us very quickly in a second. What's u to equal on this one?
Is it the second exponent in
The middle one, yeah. So what's u equal to?
1/3?
Careful, not just 1/3. Be picky here. Not 1/3.
X.
X to the 1/3. It's the middle one. It's the middle one. Okay. So if u is x to the 1/3, what's x to the 2/3? 3x. Oh, no, we're saying u's.
3u2.
3u what? 3u squared. 3u squared plus, what's 4x to the 1/3? 4u minus 4. Does that factor? I think it does. I don't know. Let me see. Yes, it factors. Okay. Okay. 3u squared is 3u and u. I want to show you something, and I never taught you this. How I know it's going to, I don't know what it factors to, but I know it factors, and here's how I did it, okay? B squared minus 4ac. I'm not going to tell you, somebody's going to tell me, okay? B squared minus 4ac. Inside the quadratic formula, remember, inside the radical, okay? B squared is 16 minus 4 times 3 times negative 4 is negative 12. Negative 4 times negative 12 is 48. How do I know it's going to factor? We got 64 inside the radical. How do I know it's going to factor? If it was 65, it wouldn't factor. 64 it factors though.
Because you can square it.
It's a square. 64 is a square. Okay? If b squared minus 4ac was 9, would it factor? Yeah. What if it was 13?
No.
Then it wouldn't factor. Now, I don't know what it factors to, but it factors. Okay? All right, so let's factor this thing. To make a negative, how to make a negative? Does it matter I put the plus minus?
Yeah, but
Because my first terms are different, so I'm putting plus minus. How do I know that? I don't. How do we make 4?
2 and 2.
Or?
4 more.
Let's try 2 and 2 first. Am I a good guesser? Or a decent guesser or a horrendous guesser right now?
Decent.
Decent, not perfect. What are my outers? Careful, negative 6u, inners. 2u, what's that? Do I want negative 4? I want 4, so what do I gotta do?
Flip side.
Minus plus. If you want to check it now, you can, but you don't need to. It's going to get us positive 4u. So what is u?
U is x over 3.
It's 3u.
Well, yeah, I know that. What is 2/3? Or negative 2. And what is u? Okay, we talked about this about a half hour ago. What's another way of saying x to the 1/3 power is the same as the what? 1/3 power. Cube root. What gets rid of cube roots? Cubes. So what do I do with these things? Cube it, cube it. What's 2/3 cubed? What's 2 cubed? Careful. 8. 2 times 2 times 2. 3 cubed is 27. Negative 2 cubed is negative 8. Those are not easy ones at all. Is there going to be questions like that in your next test? Yeah, a bunch of them, no. Like 1, maybe 2. Okay, 43. Number 43. By the way, if you really want to, you can cross off 45 through 48. I'm not doing 45 through 48, but we are going to start on number 49 eventually. Let's look at 43. Okay. So it says x to the 5/3 is 32. I don't remember if we covered this or not in Algebra 2. It was near the time when we got locked down. How do you get rid of a 5/3 power? And don't say multiply. Okay? What would cancel a 5/3 power?
Something to the 5th and then cube root it.
Yes, there's a nicer way of saying it. You're totally right, but there's a nicer way of saying it. To get rid of a 5/3 power, you raise each side to the 3/5. Raise this to the 3/5. Raise this to the 3/5. Because when you have a power to a power, you guys remember what we do if you have a power to a power? When you times, you do it with your powers. Add them. When you have a power to a power. At the top of your worksheet, you should have written this down. Maybe it was the last worksheet. x2 times x3 is x5. What's x2 to the 3rd? x6. When you have a power to a power, you times them. What's 5 over 3 times 3 over 5? X to the what? 15 over 15. And what's 15 15ths? 1. And what's x to the 1? Just x. Somebody say it. What's 32 to the 3/5 power? Somebody say it. Huh? Very good. I don't either. Okay. So we rewrite it. What's another way of saying 32 to the 3/5 power? The what root of what? 5th root of. You guys know what 32 cubed is? What's 32 times 32 times 32? Very good. I don't know either. This one I think you should know by now, though. The 5th root of 32. What do you times by itself 5 times, and it gets you 32? Take a guess if you're not sure. Little numbers get big pretty quick when you multiply them, other than 1. 2. What's 2 times 2? Times 2. Times 2. Times 2. So this is 2 cubed, which is 8. That's part A. Part B. X to the 4/3 is 16. Do not say multiply or times. That's not what I said in the last one. How do you get rid of a 4/3 power? I didn't say multiply or times. I said what? Raise it to the what power?
3/4.
To the 3/4. Raise this side to the 3/4, raise that side to the 3/4. Because 4 over 3 times 3 over 4 is 12 over 12, which is 1. Shaylin answered this last time. Somebody else answered. What's 16 to the 3/4 power? I don't know either. So it's the what root of what? 4th root of 16 cubed. What's a 4th root of 16? 2. 2 times 2 times 2 times 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 cubed is 8. Say it again, I know that. Okay, C. So we have x to the 2/3 equals negative 36. Okay. How do we get rid of a 2/3 power? Raise it to the 3/2 power. So these cancel. What's another saying? Negative 36 to the 3/2 power. The what root of what? Second root or the square root of negative 36 cubed. This one's a little different. We don't say the second root though, we say the square root. What's the square root of negative 36?
1 over 6.
Something
The square root of 36.
6.
Okay, square root of negative 36 is a negative 6?
No, 6.
No,
Huh? What'd you say?
Oh, that's not a thing.
I don't think you can get that.
No, you can't.
Careful the way you say that, though. It's
Like,
not what?
It's not 6 or negative 6.
It's not possible.
It's possible.
Not real.
It's not real. It's what?
Imaginary.
We're only dealing with real numbers right now, okay?
I
So
know.
be careful it says no, there's no answer. Yes, there is. There's no real answer, okay? Let's put down not real. Why isn't it negative 6?
Because
Negative 6 times negative 6.
is 36.
It's positive 36. Square root of a negative is not a real number. It's imaginary. And I hate that word imaginary. That's still students are like, yeah, those don't really count. Yes, they do. You know what imaginary numbers are? They're numbers. They are numbers, okay? They're just not real numbers.
Some of those like big problems no one's solved or haven't been solved because it uses imaginary numbers.
Yeah, well, okay. How do we go to 3/4 power? Raise each side to the 4/3. 4/3, 4/3. So 125 to the 4/3, what's that? I don't know. So it's the cube root. How do I remember it's going to be the cube root? How do I remember? Last thing I wrote was a 3. And I rewrite the first thing right. Cube root of 125 to the 4th. I think by now you should know the cube root of 125. That's what you should know by now. What do you times by itself? 3 times gets you 125. And be careful. Some students go like, it's like 40 something. You're adding. 40 plus 40 plus 40 is almost 100. It's like 100. It's close to 125. What do you times by itself 3 times to get 125? 5. 5 times 5 times 5. 5 times 5 is 25. Times 5. What's 5 quarters? $1.25. So this is 5 to the 4th. 5 times 5 times 5 times 5. 5 times 5 is 25. 25 or 5 times 5 is 25. You guys know what 25 times 25 is? How much is 25 quarters? Anybody know? How much is 24 quarters? There's 4 quarters in $1.
200.
So 24 quarters would be how many dollars? 4 quarters in $1. 24 would be, times 4 going to 24.
20.
6. So another quarter would be 625. I want to show you guys something here. I'll learn you something. I don't know if I ever showed this to you guys or not. How you can multiply 2-digit numbers by itself if they end in 5. If I asked you 75 times 75, it's 5625. Okay, I'll show you, see if anybody can figure out how I'm getting this. If I took 35 times, this only works for 2-digit numbers times itself, ending in, and I didn't figure this out, I read it somewhere. 35 times 35 is 1225. If I gave you I did 75, let's do 45 times 45. It's 2025. Anybody see something that kind of, I mean, what do they all have in common?
Ends in 25.
They end in 25. So if you have a 2-digit number times itself and it's ending in 5, like if I gave you
This one's kind of look like
15 times 15 is 225. They all end in 25. Now where did 20 come from on this one?
It's the first 2 digits times each other. Then well, it's okay. So if it's like 4 times.
I tell you, tell me. I'm going to give you one. If you can tell me the answer to this, what's 65 times 65?
65 times 65. That's 420.
Say it one more time.
4225.
Good, 4225. We'll try one more. How about 1, 2, 3, I've done 6 yet, 7, 8, 85 times 85.
I'm not good at 8s. 6425.
No, you messed up.
No, 50 something. I am not good at 8s.
Oh, okay. It's 7225.
So
How do you do it? It ends in 25. Where'd 72 come from?
8.
8 times 8 times 8, 64.
Oh, yeah.
8 times 9. Where did 20 come from? 4 times. Okay. So Shaylin, what is 2, 3, 6, 5, 55 times 55? Did I do that one yet?
Okay.
It's going to end in what?
30,
25.
Where'd you get 30 from? 6. 5 times the next number after 5. I mean, what comes after 5? 6. 5 times 6, then 25. All right. I'll learn you something new there. E. X to the 3 halves, negative 27. Okay. So how do we go with 3 halves power? Raise it to the 2/3. Okay. What's negative 27 to the 2/3 power? I don't know. So say the cube root of negative 27 squared. Now be careful on this one. I want to make sure you haven't misheard what I said earlier. Okay. Is this imaginary? No, it's not. If you're going, well, there's a negative in here. You can take the cube root of negative 27. You can take an odd root of a negative. What's the cube root of negative 27? Well, it times itself 3 times gives you negative 27.
3.
Careful.
Negative.
You're right, but totally wrong. Not 3.
Negative.
Negative 3. Because negative 3 times negative 3 times negative 3 is negative 27. So negative 3 squared, which is 9. Okay. All right, so cross off through 52. Tomorrow, we'll do 53, 55, 57. We'll do 4 with you guys. You'll have a work day tomorrow, and then a work day on Monday. Homework quiz is going to be Tuesday.